Hello, yes student. Today I am going to teach about the addition of 10 8-bit numbers in Keil software using 8051 microcontroller. As I already uh, project is created using project wizard in the Keil software. Okay, and this is the program I already written in the editor window of the Keil software. Okay, so here I am going to take 10 8-bit numbers represented in the hexa values in the array form, and in array is nothing but it is a homogeneous data type where I declared 10 8-bit numbers. Okay, and here I am going to perform the addition of the 10 8-bit numbers. I already wrote the program using embed C program in the Keil software. Let me build the project. Okay, after build the project there is no error. I am getting 0 error and 0 warning. After this let me debug the program. In the debugging of the program, first let me check here the values of A as shown in the debugging, as shown in the values in the debugging window. Here A of 0, A of 1, A of 2, A of 3 up to A of 9. Initial value of all the array is 0. It is declared as a 0 here, and the integer I is declared as 0 initial value, and here the sum value, initial value of the variable sum is declared as a 0. Now I am going to perform the execution of the program step by step using step option in the Keil software. The program I switched from normal mode to debug mode here in order to execute the program step by step and also for analysis purpose. Okay, and here by default all the variables it is declared as 0 in the console window here. Okay, let me click on step here A. When I click on this A of we have, and this is A is declared as array. A is equal to 1 2 3, all the values it is in the form of hexa values, it is not a decimal value. Okay, after clicking on the step option, it is going to store all the values 0x1 0x2 0x3 till 0xa in the array form of the memory location. Let me click. Before this, all the value of index of variable a is 0 here. So let me click on the step, and after clicking, all the values of a variable what I declared in the array declaration 0x1 0x2 till 0xa, all the values of a it is going to allocated in the some memory location which is shown on this below here. Okay, and next is I need to perform the addition of 10 8-bit numbers here. So by using the for loop here, I perform the addition of 10 8-bit numbers using for loop here. Before initially I am assigning I is equal to 0. I indicates index of an array. A is the array name, I is the index of an array here. Let me see here what is the value of I before execution into the step here. Here in this value of I is 0 here, which is shown here. Now I am going to execute the operation step by step in order to perform the addition of 10 8-bit numbers here. Let me click on step here. The A of 0, the A is equal to array name. A is nothing but array name. I is array index. Initially I is declared as a 0, which is shown here. By clicking the step option, this becomes A of 0. A of 0 indicates what is the value of A of 0 is equal to 0x01 here. Okay, and it is going to add with the sum variable. This is nothing but which is equivalent to sum is equal to sum plus a of I. This is the shortcut of the expression. Sum is equal to sum of a plus I. This is what we written as a sum is equal to sum plus a of I is nothing but sum plus equals a of I. It is going to perform which is same operation what I wrote the expression here. Okay, and the sum value I declared as a 0 here, and a of I is pointing to the first array value of the a of I is nothing but a of 0. A of 0 is storing 0x01 which is shown here. Okay, so 0 plus 1 it becomes 1 here. Before execution of sum is equal to sum of a plus I, let me check the sum variable is 0x00. Okay, after clicking this, the sum is stored as a 0x01 here. See here, sum is equal to 0x01 here. Okay, and the same value I am going to store into the accumulator value, accumulator register. ACC indicates the accumulator register. Okay, this variable is already predefined in the library called register51.h library file here. Okay, this is accumulator. ACC is nothing but that is the accumulator register. This variable is already predefined in the register51.h library file here. Okay, again let me execute step by step to perform the addition of 10 numbers. Now the sum is equal to 1 and now the I value is 0. By using the for loop, this is nothing but I is equal to 0. This is initialization, condition and increment or decrement operation. Here I am performing the increment operation. So now the I value is 0. After this post increment, we call this as a post increment. So I becomes 1 here. Now you check here, I is 0 here. After executing the for loop, the value of I changed from 0 to 1. Now the I is 1 here. Now it will point to the a of 1 of the a of 1 of the array here. What is a of 1? A of 1 is 0 2. Now a of 1 is 0 2. 2 plus 1. What is the value of sum? This is 1 and the a of 1 is 2 here. 2 plus 1 becomes 3 here. So now sum is equal to 3. Before execution of this instruction, sum becomes 3 here. 1 plus 2 becomes 3. The same value it is going to store into the accumulator register here. Look at here, after clicking the step option, now step sum is equal to 0x03. Same value I am going to store into the accumulator called 0x03. Again, after I added two numbers. Remaining number is left with 3, 4, 5 till 0x08. Up to this number I need to add here. Again, I am going to perform the increment operation. I is equal to I plus 1. Sorry, I is equal to I plus 1. Okay, so what is the value of I now? At this moment, I value is 1. It is pointing to the second array called A of 1, 0x02. Now, using the for loop, I am going to perform the post increment operation of I. I becomes 2 here. By clicking on the step option, the value of I it will change to 0x02. Nothing but it will A of 2. The array is pointing to the A of 2, the third memory location of array. A of 2, the value of A of 2 is 0x03. So 0x03 plus sum. Previously the sum is 3, 3 plus 3, the sum value it is going to become 6 here. Let me click on the step option, it becomes 0x06. The same value I stored into the accumulator register, it becomes 0x06 here. So again I am going to perform keep on increment the I operation, I value until the I reaches 10. Nothing but 10 is less than 10, the condition becomes fail, it will come out of the loop here. So now what will happen here? Now the I is 2 here. nothing but it is pointing to the third memory location of an array here. Okay, by clicking step option, the I value changes from 0 to 2 here. Let me click on the step option. 2 becomes 3, nothing but post increment, where it will check the condition in the for loop. What is the condition? What is the I here? The I value is 3 here. 3 less than 10. Whenever the value of I 3 less than 10 means this condition is true. Whenever this condition is true means it will perform the addition operation. Okay, it will perform the addition operation. What is the value of sum in this? The sum value is 6. And what is a of 3? A of 3 is nothing but it is 4. So 6 plus 4, it becomes 10. So let me check by clicking the step option here. Click on step option and see here sum is equal to 10. So sum is equal to 10. This is nothing but the value I am going to store in the sum variable. It is in the form of hexa value, that is 0x0a. So if I want to cross verify this hexa value into a decimal value, you just click on open your calc, okay, and open your calculator, and here you are going to choose the programmer option in your calc, okay, and type choose hexa option. Okay, choose hexa option here and click on a. Okay, this is hexa value a. So I need to confirm whether the hexa value a is decimal value 10 or not. See here in the decimal value it represents as a 10 here. So for my purpose the cross verification whether the 10 value in hexa is a, in the decimal value the 10 is 10 only, that is 10. So this is what we are going to do the cross verification whether your program is performed for your program is performed correctly or not. Okay, again I will minimize this. Again I am going to increment the I value. What is the value of I here? I value is 3 here. So I am going to perform the increment operation in the for loop. So after executing this instruction in the for loop, previous value of I is 3. Okay, let me click on this. I becomes 4. So I value becomes 4 here. Okay, now here the value of I becomes 4 here. So nothing but 4 is less than 10. When the 4 is less than 10, the condition is true. When the condition is true, it will perform the addition operation. Okay, the for loop it will keep on perform the addition operation until the value of I becomes 10. Okay, whenever 10 and whenever the value of I becomes 10, nothing but it becomes 10 less than 10. So the condition is failed, it will come out of the loop and it will stop the execution of addition of 10 8-bit numbers. Now at presently the I is 4, 4 is less than 10, so nothing but the value becomes, the condition becomes true here and it will perform the addition operation. Okay, and see here what is the value of sum here. The sum is a. By adding the a with what is a of 4? A of 4 is 5. 10 plus 5. 10 plus 5 becomes 15. So let me click on the step option and it will perform the addition. So okay, nothing but 10 plus 5 it becomes 15. In the hexa value, the 15 value of decimal can be represented as a f value. Okay, if you want you can do the cross verify using your calc in the program using programmer option here. Okay, the value of sum is 15. Again I need to perform the addition of next number, that is a of 5. What is a of 5? It contains 6. So before executing the step the value of array index is I, that is 4. Okay, nothing but I'm going to perform the execution of for loop. After executing by clicking the step option the I value changes from 4 to 5. Okay, this is a of I. Okay, the what is the value of I here? The value of I is, the value of I is 5 here. Okay, the I is I value is 5 means 5 less than 10. So the condition becomes true here. It will perform the addition operation. Okay, before performing the addition operation, what is the previous value of I? Sorry, what is the previous value of sum? The previous value of sum is f. Okay, f is nothing but 15 in the decimal. Okay, this is equal to 15 in the decimal here. So okay, a of 5, what is a of 5 here? What is the value of a of 5? A of 5 is 6. 15 plus 6, nothing but it becomes 21. How can I do? By click on the step option and it becomes 15. The 15 1 5 represents the hexa value of 21. If you want to do the cross verification, open your CalC. Okay, and here you have to choose the programmer option. Okay, it will show your all the conversions for to the different number system here. Okay, and here I am going to check whether the hexa value 15 is 21 or not. Just you click on to 1, you click on this, sorry, you have to click on, sorry, 1 second. Okay, just you have to click on here. What is the 1 5 hexa values 1 5? Click on, I had to choose hexa option and click on 1 5. Nothing but the decimal values 21 here. So 15 plus 6 is nothing but 21. That is equivalent to 1 5 in the hexa value. Okay, so in this way you can do the cross verification with the hexa value with decimal value using your CalC. Okay, so let me keep on execute until the value becomes 9 here. Okay, let me keep on execute until the value of I becomes 9. Okay, by clicking on step function and keep on watch till the value of I becomes 9 here. Okay, the I value becomes 6. Okay, it perform the addition. Next, I value becomes 7 and it will perform addition. Again, I becomes 8. It will perform addition. Now, again, the I value becomes 9. The I, next it will perform the addition. Okay, and next the I value is 9. Till I value is 9 means it perform the addition here. When the value of I becomes 10, okay, let me check here. Now the I value is 9. Till that it perform the addition. Let me click on the option step and click on step option. The I value changes to 10, which is nothing but a in the hexa value. So what will happen? The I value is 10. Nothing but here it will show as a 0x0a. Okay, so 10 is less than 10. See here, the I values 0x0a. Nothing but that is the 10 in the and 0x0a, that is in hexa value. So what is the hexa value of 10 in the decimal? That is 10. So 10 is less than 10. The condition is failed. So it will come out of the loop and it will stop the execution of addition of 10 8-bit numbers and it becomes execute while of 1. Okay, so while of 1 is nothing but it keeps, this is infinite loop. Okay, nothing but my program becomes halt because while of 1 is nothing but the condition is keeps on, the condition is always true. When the condition is always true, it will my program becomes halt condition. If you click n number of times, the program will stay here, nothing but your program becomes halt. Okay, so finally what is the final sum value here? The final sum value is 0x37. This is hexa value. What is the addition of 10 numbers? The addition of 10 numbers, let me see here. Okay, let me clear this. Addition of 10 numbers, 1 plus, okay, sorry, let me choose, go to clear option, let me decimal option. Okay, addition of 10 number, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 is equal to 55. Okay, this is the 55 addition of 10 numbers 1 to 10, which is equal to 55. What is the 55 in the XR value? That is 37. The 37 in the XR value represents the 55 in the decimal value. Here, if I check here, see here, the final value of adding of 10 numbers in the XI value, it is given as 0x37, which is nothing but equal to 55 in the decimal value. So this is what you are going to do, the cross verify whether it is going to perform the addition of 10 8-bit numbers properly or not. Okay, if you want to give other values and you verify whether it is going to perform or not properly, and we can do the cross verification using CALC option. Okay, thank you.